let's look at this shifting behavior a little bit more. That's a little bit harder to understand. The change of amplitude that we get when we multiply y by 4 is pretty easy to understand. If we had y equals 4 sine of 2 pi over 8t, the graph would be like this. If we want the graph to be like this, starting at the pi over 2, we've got to add the pi over 2 so that at t equals 0, the angular position is pi over 2 and gives us this point. We see that adding the pi over 2 has the effect of shifting us to the left 1/4 of a cycle. So the shift is negative pi over 2 radians. Now that's the shift in the angle, and that corresponds to negative 2 seconds. Since recall the period here, as we see here with the 8, is 8 seconds. So if we shift 1/4 of a cycle, we shift 1/4 of a period, 1/4 of the 8 seconds, and that's going to be 2 seconds, and we're shifting to the left, so that's a negative 2 second shift. Now how can we see that negative 2 second shift? Let's just try to look at everything in perspective here. Okay, again, the theta shift is negative pi over 2 when we add pi over 2 here. In order to find this 2 second shift, we factor the 2 pi over 8 out of this expression. Now when we factor something out, we essentially divide everything in the expression by what we're factoring out. If we divide pi over 2 by 2 pi over 8, we end up with 2. You can do that division. You can figure that out for yourself. I don't have to explain that. In any case, when we factor out the 2 pi over 8, we're left with a t plus 2. And that corresponds to our t shift of negative 2. So when we have the function in this form, we can just read off our t shift. When we have everything factored out, so we just have a t plus or minus something, our t shift will be the negative of whatever we have. Before I summarize this, let me digress to the fact that I'm still writing 2 pi over 8. Now that obviously reduces to pi over 4, but I'm writing it in this form to emphasize how the period works in here. Okay, when we report this in final form, we're going to reduce everything to lowest terms. But right now I'm leaving everything in its most elemental form so that we can see what everything means. Now, our general form for the function is y equals a sine of bt plus c. If we write a sine function in this form with the bt plus c, nothing factored out, then we have the shift in the phase, or theta, the angle. It tells us how much the angle shifts, and it'll shift by negative c. If we put it in factored form, y equals a sine of b times the quantity t plus h, and of course h here would be c over b if we factored out of this form, then we see that the t shift is going to be negative h. And this tells us again how the graph shifts right and left.